Hello, I hope everyone's doing well. What we're going to learn today is how to find the angle between two vectors. So it's really not that hard of a process. There's a formula that we're going to need to use, and we're just going to do some algebra to get that angle. But let's look at the idea graphically to see what we're doing. So we're going to have two vectors, u and v, and they're connected by a central point here at the origin. The vectors are going to be in component form, so when they're in component form, they're connected via the origin. So remember, the component form of vector v is v1, v2 in that bracket notation, and the same thing for the vector u, u1 and u2. So we're going to try to find this angle in between theta. Now it's important to note that this top line connecting the ends, the terminal points of u and v, we can form a triangle by subtracting vector v minus vector u, and that would form a new vector. That's going to come in handy in the future, but we'll practice that more down the road. Okay, so let's look at the equation that we're going to use to solve these problems today. It's going to be cosine of theta is equal to the dot product of uv and the magnitude of each vector times each other. And remember that the magnitude of a vector in component form is just the components squared and added to each other. So we're going to use that to solve these problems. So let's look at an example. All right, so let's say we have vector u, which is given by the component form 4, 3, and vector v, which is given by the component form 3, 5. And we want to find the angle in between these vectors. So let's graphically look and see what's going on. I'm just going to draw the first quadrant here. So if we graph vector, let's use a different color for each vector. So if I'm going to graph vector v, I need to go over 3 on the x and up 5. 5. And that vector is going to look like that as a graph. Vector v, and let's use a different color for u. So for vector u, I'm going to go over 4. So 1, 2, 3, 4, and up 3. So I'm going to be right here. It's a terminal point. So what we're going to look for is this angle in between theta. We want to figure out what that is. So let's do the operations with the formula. So let's write down the formula. It's always important to write down the formula whenever we're solving these problems first, just so we can get the formula in our head, even though you're going to have these formulas available on a formula sheet. So make sure you write this one down and add it to your formula sheet. So the magnitude of u times the magnitude of v. So let's plug these values in. So the top is just going to be the two vectors. The dot product. And the bottom, we're just going to have the magnitude of each vector in each component form. All right, so the top, it's going to be 3 times 4, it's going to be 12, plus the second term, 3 times 5, which is, actually should be a little bit more explicit there. So the first term is going to be 4 times 3, which is this 4 here and this 3 here. And let's use a different color. And the second term we're going to multiply is 3 times 5. Now the bottom we can simplify as well. So we need to do the square root of the magnitude. So it's going to be 4 squared, which is our first term, plus 3 squared. We got to do another square root of 3 squared, which is our first term, plus 5 squared. So we can remember this is all equal to the cosine of theta each time. All right, so now we just have to do some algebra to simplify this up a little bit. So the top is going to be 12 plus 15. Okay, so that's going to be 12 plus 15, which equals 27. Now the bottom, let's work on this one a little bit. All right, so this is going to be the square root of 16 plus 9. Okay, so it's going to be 16 plus 9. And this one's going to be 9 plus 25. 9 plus 25. Just double check that's good. So that's 16, that's 9. This is 9 and 25. This checks out. So let's simplify it up a little bit more. So the left one is going to be 20 square root of 25. And this is going to be 34. Okay, so we can simplify the square root of 25. So let's just do another step here. The top is 27. Square root of 25 is 5. We're going to keep the positive value of 5. And we can't do anything to the square root of 34. So we can keep it like that. All right, so far we have cosine theta equals 27 over 5 times the square root of 34. So remember, we want to get an angle, so we got to do the arc cosine of both sides to get rid of that. So we got to do arc cosine of both sides. Okay, so that's going to cancel that cosine. You get theta by itself. Remember, in your calculator, the button you're going to use for arc cosine is that cosine inverse button. And also just double check your calculator has to be in degrees in order for this to work out. So when we put this in our calculator, now we want to remember we want to put all of that in the calculator. So do the cosine -1 parentheses 27 divided by 5 times the square root of 34, just so we get an accurate answer. And we'll get about 22.2 degrees when we get done with that. So if we go back to the diagram, this angle would be 22.2 degrees. All right, let's look at one more.